Happy Friday, everybody. Or if it's Thursday, I hope you have a happy Friday tomorrow. Or if it's Saturday or Sunday, I hope you had a happy Friday yesterday or the day before. Today, I want you to learn two new things, and they're brand new things, so be ready to really tune in. I want to teach you today what variable expressions are and how to tell if two variable expressions are equivalent. You'll notice these are brand new words, so we're starting a kind of a brand new thing today. So let's go back to something you know. That's the wrong one. There. So, you already learned how to deal in the past with algebraic equations, inequalities too. We talked a lot about these, and you did this example back in your what should you be forgetting today. This is a variable equation. It has a variable in it. You find out what the variable is. So, we know how to deal with that, but what about something like this? This is an algebraic expression. So what do you do with this? Pause here, jot somewhere on your notes page or on your what you be forgetting today or some scratch paper somewhere. If you already know how to do, I'm out of order, drama is ruined. You already know how to do this. What about this? And unpause when you're ready and we'll move on when you've given it some thought. That's where we are. That thing you just tried to deal with and tried to find a solution to is called a variable expression. I want to teach you what to do with those and then talk about how to tell if several of those are equivalent to each other. So I'm going to be giving you some new success criteria tomorrow, but just so you know, we're kind of moving on to a new topic here. And the ones we're going to start to work on today are especially, you'll notice, equivalent expression, equivalent expression, equivalent expression. It's in there a lot of times. So today, I don't think we're going to address any of these completely on their own, which is why I didn't give you these yet. But we're going to be starting to, and you'll notice this terminology, variable expression, algebraic expression, equivalent expression that are in the title are coming up. So this is sort of our background day to get ready on all this business. All right. So right now, I want you to have nothing in your hands. You don't need to write anything. You don't need to take notes at this time. All you need to do is fully concentrate on what I'm doing, what I'm saying, and just kind of take it in. I'll let you know when it's time to write. You do have a notes page. I don't want you to feel any pressure to do that now. You don't need to write everything I'm saying. So this is a variable equation. Variable equations have an equal sign. You notice they pretty much have the word equal in them. They have an equal sign. And they have a solution. We found this with an inverse operation, x equals 8 6/10. This expression, if I were to tell you, well, what is x equal in this expression? You can't. It doesn't have, there's not enough information with no equal sign for you to tell me what the variable is. You can't find a solution to an expression. All you can do with an expression is say what the solution would be if I told you the variable. So what we often do is I kind of make a t-chart to organize myself, and I kind of say, well, if x were equal to whatever, then the expression would equal what? Like if x equaled 0, then the expression would be 10 times 0 equals 0. If x equaled 1, then the expression would be 10 times 1 is 10. If x equaled 2, then the expression would be 10 times 2 equals 20. If x equals 3, it'd be 30. And I could keep doing this. I'm going to go on and on forever. I usually do 0, 1, 2, 3. You could even do like decimal numbers. I could do if x equaled 2 2/10. I just don't really need to. This is the main idea. All I can do is say, well, if I choose an x, this is what happens. That's the difference. Equations, you can find a solution. Expressions don't have a solution. All you can do is evaluate them for different amounts. So that takes, I'm not going to yell it because I need to have headphones on or something. So I'll just keep it tame and boring. So the first big idea I want you to have today is this. In algebra, sometimes we deal with equations. Sometimes we deal with expressions. We can deal with both of them. Expressions with variables have a solution. Expressions with variables do not. They sort of have this if-then solution business that I just did before. If x equals 0, then the expression equals 0. If x equals 1, the expression equals 10. And so on and so forth like that. So the next thing we talk about with expressions is whether or not different expressions are equivalent. So here I have 3 different expressions, 10x, 10 times x, 9 times x plus another x, and x plus 10. So these don't have solutions, but what I can do is start to look at them all. If x equals, then, so this one I just did. If x equals 0, 10 times 0 is 0. If x equals 1, 10 times 1 is 10. If x equals 2, 10 times 2 is 20. If x equals 3, 10 times 3 is 30. That's usually enough. I usually do 0, 1, 2, 3. You can do whatever you want. Let's do this one next. This one's a little more complicated. There's 2 operations, multiply and add. In the correct order of operations, you always multiply first, add second. So just to make sure I do this in the right order. So if x equals 0, this is 9 times 0 is 0, plus 0 is also 0. If x equals 1, this is 9 times 1 is 9, plus another 1, x is 10. If x equals 2, 9 times 2 is 18, plus 2 is 20. If x equals 3, 9 times 3 is 27, plus 3 is 30. And you'll notice, no matter what x I choose, I always got the same thing on those 2. They have the exact same set of solutions, so we would say these 2 are equivalent expressions. They always have the same outcome, no matter what I make x. If I go to this next one, I'm going to get whole different stuff. If x equals this, then what? So if x equals 0, 0 plus 10 is 10. You'll notice not a match here and not a match here. If x equals 1, 1 plus 10 is 11. Not a match here, not a match here. If x equals 2, then the expression equals 12. Not a match here, not a match here. So this one is not equivalent to the other 2. It's just a different expression. So we say expressions are equivalent if they match every single answer, no matter what you choose for x, which I dare say, oh, I thought it was a big idea slide, must be coming. So here's another example that I'll work for you too. Which of these are equivalent? Woo, there's a lot of them. I'm just gonna dig right in. Let's start here. If r equals, then, so if r equals 0, I get 4. If r equals 1, I get 5. If r equals 2, I get 6. Okay, over here, r plus r plus r plus r. If r equals, then, if r equals 0, then I got 0 plus 0 plus 0 plus 0. If r equals 1, 1 plus 1 plus 1 plus 1. If r equals 2, 2 plus 2 plus 2 plus 2 plus 2. You'll notice these 2 are not equivalent. I get totally different outcomes than I got over there. How about this one? If x equals, then, if x equals 0, 4 times 0 is 0. If x equals 1, 4 times 1 is 4. If x equals 2, then 4 times 2 is 8. And you'll notice I've got a match, and those 2 are equivalent. Okay. What about this one? R times R times R times R. If x equals, then x equals 0. Got 0 times 0 times 0 times 0. That's 0. Looking like a possible match here. If x equals 1, I've got 1 times 1 times 1 times 1 is 1. And I, in fact, do not have an equivalent expression. I've got something totally different. Didn't match for all of them. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. And I definitely don't have a match. So the only equivalent ones I have here are this one and this one, because all of their outcomes match no matter what x is. And that's what I thought was coming. That indeed is a big idea. 2 expressions are equivalent if they always have the same outcome. Our first big idea, since I'm just about to have you write it down, is this: equations like x plus 8 equals 10. I'm going to even expand this to say variable equations. A couple of things to know. mainly that they, I'll just do the one. The main one to know for this is they have a solution. Right? The equation here, x equals 2. We can figure out what x is. In an expression, we can't. X plus 8. What's x? Don't know. All we can do is something like this. If then. If x equals 0, we get 8. If x equals 1, we get 9. If x equals 2, we get 10. If you will, please pause here and get this big idea in your notes, or these two big ideas on your notes page. We've got a few examples to write in your notes page coming up. I'm going to do those on the next video. Make sure you concentrate while you write this. Think it through. Scroll to the next eClass page when you're ready.